Hello friends, welcome to my channel Selected Topics in Physics. Today I will discuss about one interesting thing, that is the gravitational force and how it varies with the distance. So that I will discuss using LabVIEW program. Okay, so let's start. So this is the right side, as you can see, block diagram, and left side is the front panel. So I will do some programming here. So first I need, as you all know, the gravitational force F. There are few terms. One is gravitational constant, that is G, and two mass parameters m1 and m2, and the distance between them, that is r. And the force F is G m1 m2 divided by r square. So you can write it F, or you can write it here, F equal to G m1 m2 divided by r square. Okay, so this is the gravitational force. So to understand it clearly, make it a little bigger. Okay, and this we can see the size, maybe let's say 34. Okay, it's fine. So now we need G, m1, m2 and r, and the output is the F. Okay, so let's start. So to understand this, I will go to first numeric, and then I will choose multiply, because there are few multiplication, that is G m1 m2, and so I need one more multiplication symbol, Control C and Control V, that is paste. Okay, now here I will include, that is create control. So this is the m1, then create another control, this is m2. So we can additionally write it here for better understanding, m1 m2, one more G. So G is a constant, so this I can use it like that. Okay, so I will connect this here, and then create. You can put control also, but here you can use constant also, but here I am using control so that I can see from the front panel. So this is the G, gravitational constant. Okay, now G m1 m2 I have done. Now it is required R. Okay, so I need r square, then I have to do it reciprocal. So I am going to again numeric, then square multiply. So if I give it here, uh, okay, or instead of that I can choose square. So this I create, and then control. Okay, so this is the R, and this is the r square. Then I have to make it reciprocal, go to numeric, reciprocal, here is reciprocal. So now it become r square. Okay, now I have to multiply again all these parameters. So again I have creating Control C, Control V. So it will go to the here, and then it will go to the output of 1 by x. So now it becomes G m1 m2 divided by r square. So I need here, this is the output, create indicator. So this is the F. This is the F. This is the gravitational force. Okay, now if I want to see the variation with the distance, I have to change the r value, or I have to take many points to understand it in a graphical way. Okay, so to understand that I have to use the one structure. So let's choose for, then make it including all these things. Okay, fine. You can bring all these things outside as well or inside. So I am making all the outside the loop. Okay, fine. So this is the gravitational force. Now here I have to make some iteration. For example, create control. So this is the number of numerics or number iteration I can put here in. Okay, it's fine. Now to understand in a better way, let's give some time delay. Wait, so this I am giving here, let's say 1500 means 1.5 second. Now we need to create graph. Okay, so to represent in a graphical way, I need variation of r, because g, m1, m2 all are constant. So I want to see the variation of force with the distance. So this is the r. So let's delete this part and make one using one numeric, and like uh, numeric add. So here I will use this I. So I will start from 0 and it will continue till n minus 1. So here this will go, and then this value will go to the x square, so that it will vary, so that I will get different r value. Okay, okay, make it a like this way. Now I need to see the graph. Let's make it smaller. Okay, so I'm going to front panel. This is the graph, expressed xy graph. So let's choose two graph. Why I am choosing two graph? Make it in a site. Okay, then let's say copy and paste. So two similar graph I am giving. So here this I choose this point and this choose same. Okay, so here this will be the distance. Here also distance, and in the amplitude property I have to go to property. So new pop-up came. So in the scale, x is fine, y axis I have to change, plots, display format. Okay, so here deleting this I have to make it a scientific notation, insert into the string. Okay, not this, because x is fine. So let's make it, so y axis I have to change. Instead of floating, I make it a scientific notation, insert, and click OK. Similarly also, after going to the properties of this graph, display x is fine, y axis I am making it a scientific notation. Okay, then okay, fine. Okay, so going to the next block diagram. So here is my graph. So let's go to this. Here is the graph one, bringing it to the inside. Okay, next graph is here, but I have to also make one copy of this. Okay, let's create another one. Expression of graphs. It's the distance, and the scale I have to change it. X is fine. Y I have to make it a scientific notation. Okay, now it is fine. So this graph, make it here. So I have two graphs. So I added two graphs to represent the force variation with the distance, and how it varies to the gravitational potential. That variation will be the 1 by distance. So here x will be the distance that will vary. So here also x input will be same. So 1 y will go to the output. So reset, create constant. So make it false to understand in a proper way. So reset also, create constant, then make it false. So now this is the force, how it will vary with the distance. So now how it will vary with the 1 by r. So for that 1 by r, so okay, so here I have to make one arrangement. So if I use initially 1 by x, then if I make it square, then I can take this wire from, it will be easier. So let's do that. Then the square, numeric, then the square. So this square will go here. Okay, so now this 1 by r I can take, and this. Okay, fine. Actually it will not show here. I cannot show the constant value because this is showing in the force. So in this variation, that is 1 by r, so here I will show only the how it varies with the distance. This is the uh, one can say how it will show 1 by x or 1 by r. Okay, so let's go to the front panel. Okay, so now m1 we can give maybe 2000, m2 we can give 1000, and gravitational constant is 6.67, 10 raised to minus 11 in SI. So R you can give maybe 20 meter. So iteration you can give around, let's see, 20, and let's run the program. See, it is changing. This is the amplitude versus distance. The first one is the force, and this is the potential. So potential axis, y-axis, the value will not be exactly same because I did not use the constants, but here the value will be the same. So let's see how it is changes. So as you can see, as you have read in the books, that it will vary with 1 by r square in the force and 1 by r in the potential. So you can use it this way to understand the every points. So if you understand, if you give more points, then it will show more broadened in terms of distance. So let's see that. Okay, so initially looks like it's straight line, but it is not a straight line. It will vary 1 by r square, and right side it will vary 1 by r. Okay, it will take some time because I gave 50 iteration or 50 points. Sorry, I gave 20 iterations, but distance I have changed. It is 20 meter to 50 meter. Okay, so if you change it from 20 iteration to 50 iteration, it will go till beyond. So let's see that. So likewise, you can use Coulomb's law to represent in LabVIEW program and to see how Coulomb's law will vary with the distance between two charge. If you consider two charge Q1 and Q2 and you are keeping separated them around the distance, so then you can calculate same things and you can visualize this variation using LabVIEW program. So you can try in your own and see how it is varying, and if you encounter any problems, so you can write in the comment box. So till it is going, so total iteration will be 50. Okay, so you can make the graph bigger by, okay, now it will not happen, so let's complete them first. So you can see the variation of 1 by r square and 1 by r. So each point or each distance you can see how it varies. Okay, so you can make it a little bigger to understand or to see in a better way. Okay, see how it is varying with the 1 by r square and 1 by r. So this is how we can use LabVIEW program to visualize gravitational force and potential. Okay, thank you for watching.